This is problem 28 from section 4.1. We're asked in this to take this initial value problem, determine the amplitude, phase angle, and period of the motion. So what you would need to do first is solve this equation, and the way that we most often solve it is by going right to excuse me, x of t being some constant times cosine, right, omega naught t, excuse me, that was terrible, why did that happen? Omega naught t plus c2 sine omega naught t. Now, in these cases, recall that this term, the omega naught, that value, is the square root of what we called k over m, where m is 1, k is 16, so the square root of 16. So it's 4. To find the two arbitrary constants, we need to plug in our initial values. So with a 4 there, you notice when I plug in these initial values, I can do it directly right now for x of 0, but in order to plug in this initial value, I will need to take a derivative. So let's maybe just write out what we know. So x of t is equal to some arbitrary constant, cosine of 4t, plus some arbitrary constant, sine of 4t. If I stick it in the first initial value here, so x of 0 is equal to c1 cosine of 0 plus c2 sine of 0. Well, the sine of 0 is nothing. So, and the cosine of 0 is just 1. So this gives us c1, and that we're given is equal to 0. So that tells you your first constant is 0. Hence, our solution progresses. Now we could say our solution has been determined to just be c2 times the sine of 4t. That's where we are now. In order to find the second arbitrary constant, we want to use this, but that would require taking a derivative. So let's do that. So x dot will be 4 times c2 cosine of 4t. If we stick in that initial condition, that tells me x dot at time 0, which in this case is equal to 4 times c2 cosine of 0 is just 1. That is equal to 4 we were given. And this solves very easily to c2 equals 1. Thus, our general solution to this problem, so x of t is equal to, using this equation here, just sine of 4t. So what's sort of interesting about this particular problem is it asks us for the amplitude, phase angle, and period of the motion. And our formula was in terms of cosine, so we could put it back into cosine, although it is possible to talk about it in terms of sine. So we can use a very sort of simple trig identity to say, well, if I want to change the sine to a cosine, they're complements of each other, so we just subtract off pi halves. Alright, once we have this form, we're ready to answer all of our questions. So if you look back on page 199 in the textbook, that's where they really define a lot of our different values. Our amplitude is whatever number is multiplied in the front here. So we can say pretty easily our amplitude is 1. Our phase angle, which they gave as this little delta, right, is whatever's being subtracted off after the 4t. So this one is pi halves. The period of the motion, well, the period, which is given as capital T, that is 2 pi divided by omega naught. We actually could have found this one way back in the beginning, since we knew omega naught was 4 for a long time now. So in this case, the period is pi halves as well. And that is what the question wants. Sometimes I find it helpful to think about what this would really look like. So the idea here is if we graphed it, let me make some axes here. The amplitude tells you sort of the high and the low values of it. So in this case, it's going to go up to 1, down to -1. So the amplitude is not the total difference, right, but just from sort of the equilibrium from the middle. In this case, the period tells you it's going to do a full sort of circuit every pi halves. And the phase angle tells you how much has been sort of shifted off. So in this case, you would notice that our picture looks something like this. I'll draw two periods here. And it says it takes, so say this is a mark to a mark, that's going to be a distance of pi halves. So that's the idea of a period there. You can measure it also if you wanted from, say, maybe take red from here to here, right? Pi halves, here to here, pi halves. There's 0.5 halves, here's 0.5 pi. So there's your period. Your phase angle is important, but your phase angle itself doesn't show up directly, because if you're looking for your phase shift, that's often what people think about, which sort of says, well, how far has my peak been moved? So this is sort of the cosine function. So it starts out at a peak when you start from 0, etc. And so this shift right here, that can be called your phase shift, and that's given as delta divided by omega naught, or in other words, pi halves divided by 4. So that's pi eighths. Yep, and so that's sort of what all these things indicate.